Hello, and welcome to our presentation on keyword extraction presented by Alina Kraus, Brandon Q, and Carlos Salazar for Information Retrieval Course CAP 6776. Here is a brief overview of our presentation on keyword extraction. We will first discuss some background information regarding what a keyword is, then provide a general overview on keyword extraction along with some major problems addressed with the technique. Next, we will discuss some methods and approaches with keyword extraction, then talk about the various applications and use cases of the technique, along with some problems that have yet to be addressed and future research in this topic. We will then include some concluding remarks on our presentation. So, before we can begin discussing the technique of keyword extraction, let me provide some background information on what a keyword is so we can better understand what the term keyword actually entails. Simply put, keywords are important phrases within documents. They are words or phrases contained within documents that generate sense when they are clustered in context. The word keyword is not solely limited to terms, more on what a term actually means, but they refer to key elements of a document where a key element can consist of varying lengths and structures. To elaborate more on the definition of a term, it is a polysemous word used in computer science and information retrieval that refers to both the linguistic unit of terminologies, which labels a concept, and to the index term or descriptor, which are both expected to describe a document content and are part of a controlled or indexing vocabulary. So, carrying on with what a keyword is, essentially, if we were to have some element with respect to some document that is an essential descriptor of the document content, then this is what is defined as a key element or a keyword. The motivation behind using keywords. So there is an abundance of various documents that are available across a multitude of mediums. This massive abundance of documents has made it become infeasible for any one user to read through all these documents in detail. Utilizing keywords provides an effective method to retrieving relevant information to a user by highlighting the subject of a document. Keywords play a vital role in numerous text processing applications, such as text mining, information retrieval, and natural language processing, to name a few. Keywords are used extensively with query processing within information retrieval systems, since they are easy to define, revise, remember, and share. Keywords have also been used to improve information retrieval system functionality, where they are used to build automatic indexing systems for a document collection. Now we can move on to what the keyword extraction technique is. So keyword extraction is a technique that enables the identification of lexical units that best represent a given text. So it is primarily a text analysis technique that automatically identifies these units in a document. The goal of this technique is to deconstruct the human language to obtain any key phrases, segments, or terms. Keyword extraction is independent of any corpus, and its methods can be applied across multiple corpora and information retrieval systems. Keyword extraction is a fundamental technique in many information retrieval and natural language processing applications, These applications include automatic indexing, automatic summarization, document management, high-level semantic description, text, document, or website categorization or clustering, and many others. In the next slide, I will cover some examples of the keyword extraction technique. Here are some examples of the keyword extraction technique. So the example provided here is an example of keyword extraction on some sample of text. So here in this GUID, we see that after some sample text is inputted, which in this scenario is sample text from a news article, the keyword or phrases are extracted and grouped utilizing some method of keyword extraction. The extracted keywords or phrases are then displayed and provide a readable and succinct summary of the original article. Another good example of using keyword extraction is with analyzing client feedback. So analyzing client feedback through traditional means, like manually reading through the reviews in detail, can become very tedious and inefficient for organizations and brands to determine what customers like and dislike, especially since the amount of client feedback can range in the thousands. So utilizing a method of keyword extraction can help these organizations in analyzing client feedback by extracting keywords or phrases that highlights a client's views on a product. This will then make it easier for these organizations to gain insight on customer opinion. What are the major problems associated with keyword extraction? The primary challenge of keyword extraction involves the number of diverse types of documents and the type of keywords that are needed to be extracted. This results in a lot of difficulty in automatically extracting keywords. With this vast amount of documents, grew numerous methods and tools for keyword extraction to accommodate these various applications. With such a large number of methods and tools that can be used, there is no one method that is considered standard or is solely responsible for effectively extracting keywords from every single data source. Highlighting keywords on its own presents an issue, as it can be challenging to pinpoint keywords or phrases from unstructured documents that contains content that is expressed in natural language.
There are many methods for performing keyword extraction. These approaches can range from simple statistical approaches to complex deep neural networks. Simple statistical methods are easy to explain and are language and domain independent, so they can be applied to a variety of different types of texts. These approaches often involve word statistics, such as use of n-grams, word frequency, and TF-IDF calculations. Linguistic approaches use the linguistic features of the words, mainly sentences and documents, as features. Lexical, syntactic, semantic, and discourse analysis are some of the most common linguistic approaches. Machine learning involves supervised or unsupervised learning from examples. The process involves construction of a model, which is trained on a set of keywords. Supervised methods require manual annotation in the learning dataset, which can be costly but also highly accurate. Other methods often involve the combination of these approaches. All of these methods may be applied using a vector space model, which we have studied extensively in the information retrieval course, and also graph-based text representation, which will be discussed in later slides. One common statistical approach to keyword extraction is the RAKE algorithm, or Rapid Automatic Keyword Extraction Algorithm. The input parameters for RAKE comprise of a list of stop words, a set of phrase delimiters, and a set of word delimiters. Rake uses these stop words and phrase delimiters to position the document text into candidate keywords. Co-occurrences of words within these candidate keywords are meaningful and can be used in the term scoring. The candidate words are ranked by their scores and are used to extract the final keywords for a given text. Let's take a look at an example of rake. Here, the document text on the far left is split into an array of words by the specified word delimiters that we talked about previously. This array is then further split into sequences of contiguous words at phrase delimiters and stop word positions. Words within a sequence are assigned the same position in the text and together are considered a candidate keyword. From the example text, we can see some extracted candidate keywords here at the bottom. These include words like compatibility, systems, criteria, and solutions, along with phrases such as linear constraints and natural numbers. From the candidate keywords, we can construct a word degree or co-occurrence matrix, where each row displays the number of times a given candidate word co-occurs with another candidate word. So from this chart, for example, we can see that the word algorithms co-occurs once with the word corresponding, while the words minimal and set occur together twice within the document text. After every candidate keyword is identified and the co-occurrence matrix is complete, a score is calculated for each of the candidate keywords and defined as the sum of the member word scores. So for each candidate keyword, any of their member words have a given score, and the entire keyword has a score, which is the sum of the member word scores. Metrics for each of the words are calculated based on the degree and the frequency of the words. So the first metric we have is word frequency, then the word degree, which is the co-occurrences, and finally the ratio of the degree to the frequency. After the candidate keywords are scored, the top T scoring candidates are selected as the final keywords for the document. We can compute T as like 1/3 of the number of words in the keywords, or some other threshold can be used depending on how many keywords you want to extract for a particular text. One other statistical method for keyword extraction is the YAKE algorithm, or yet another keyword extractor. And this method uses statistical features from a single document to extract the keywords. The algorithm consists of the following major steps. The first is text preprocessing, which is pretty standard for all of the keyword extraction methods. Then we identify candidate terms, perform feature extraction and term scoring. Then we do n-gram generation and data deduplication. Finally, we do some ranking to extract the final keywords for the document. Going into a bit more detail about the YAKE algorithm, in the pre-processing stage, we do candidate term identification. This is all kind of combined into one step. So basically the text is split into sentences and chunks, and it's tokenized. The text is cleaned and tagged, and finally the stop words are identified. We also perform sentence splitting and text annotation. Then we represent the individual terms as statistical features. These statistical features include term frequency, sentence index, acronym term frequency, and uppercase term frequency. Such features are later combined to calculate a single score that reflects the term importance. From here, candidate words are generated and distance measures are used to calculate the similarity. Finally, the keywords are sorted by their relevance scores. We will go into some more detail about this approach in the next slide. As I mentioned before, the individual terms are represented as sets of statistical features. Going into a bit more detail, these statistical features are combined to extract new features, which includes the following attributes. We have casing, which counts the number of times that a term appears uppercase or as an acronym in the text. A significant term usually appears uppercase more often. Then we have term position, which is the median position of the term's sentence in the text. Terms that are closer to the beginning are often considered to be more significant. Then we have term frequency normalization, which measures the balanced term frequency in the document. Then we have the term relatedness which measures how many different terms the candidate term co-occurs with. More significant terms tend to co-occur with less different terms. And then finally, we have the term different sentence metric, which measures how many times the terms appear in different sentences. A higher score typically indicates a more significant term. So all of these features are used to calculate the score shown using the equation at the bottom here. Moving on to some machine learning based approaches for keyword extraction, we have unsupervised methods, which often include clustering and semantic analysis. One paper proposes such a method that operates off of semantic similarity, and we'll take a closer look at this. There is 3 main steps in the proposed system. Pre-processing is performed via text filtering, stop word removal, and stemming. Then the text is divided into sentences. The semantic analysis aspect of the implementation deals with solving the word sense disambigued problem, which I'll discuss later. Ultimately, there are pairs of words that are generated for each sentence, and the similarity is used to perform the clustering. Going a bit more into detail about this specific unsupervised approach, the word sense disambiguation problem is a very famous natural language processing problem, which involves the identification of the meaning of a word or the sense of a word. To solve this problem, the system that's proposed makes pairs from the target words and all of the words that appear in the same sentence. So for example, if we have the sentence, the baseline of the song is too weak, the extracted pairs would be bass line, bass song, and bass weak. And from here, these pairs can be further analyzed using things like WordNet to extract the meaning and the sense. From there, the extracted pairs we can use to perform clustering. Every cluster will refer to specific meanings, so the size of the cluster reflects the importance of the meaning of the words that belong to that cluster. So the cluster with the highest number of pairs is more likely to be the cluster with the highest number of keywords. And so from every cluster, depending on the size, the proposed implementation selects a number of pairs with the highest frequency as the final keywords. Some supervised machine learning approaches to keyword extraction often take the form of a binary classification problem, which are types of problems that we've studied before in the information retrieval course. That is, the model should determine whether a word is a positive keyword or a negative class, not a keyword. Oftentimes, the most significant features include the word frequency and the term location. One major disadvantage to these supervised approaches are the demand for training data and the manually annotated instances. There could be also bias introduced when we are talking about domain-specific content. Many of these methods utilize a graph-based approach to explore the relationships between the terms. Also, some of the previous methods that we talked about may use this graph-based approach. I will discuss this implementation and how graph-based representation works in a later slide. But overall, some of the most popular approaches for supervised keyword extraction include naive Bayes algorithm, decision trees, neural networks, and support vector machines. We will take a look at one example which uses the support vector machine approach. In this paper, a supervised learning technique that uses statistical features and support vector machine classifier was implemented and applied to extract the keywords from Arabic news documents. Recall that the support vector machine tries to find the best hyperplane to separate classes with the highest margin between the hyperplane and the data points. The overall process here involved splitting the text into sentences, cleaning the text, performing tokenization of the text into words, and then from here the words with similar stems are grouped together and statistical measures are calculated to serve as the features for the model. This includes the TF-IDF and the first occurrence index of the word. Data balancing is applied to ensure that the model learns the specificities of the training data, so keywords make up approximately 1/3 of the sample. The support vector machine is fed the features along with the corresponding manually annotated labels. in order to perform the classification of a word as either a keyword or not keyword, and for finding the best hyperplane dividing the instances. Graph-based representations are used to explore relationships between words in text. So these graph-based methods generate graphs of related terms from the documents. In a graph, there can be vertices, which represent the words with edges to indicate relationships between the words, and these edges can have different weights and values, including co-occurrence relations, syntax relations, and semantic relation values, among other things. The graph-based approach can use different graph-based algorithms to exploit some of the graph properties to solve some of the keyword extraction problems. And this representation can also be applied to some of the supervised and unsupervised learning techniques that we've seen in this presentation, along with the vector representation that we've studied in the course.
Now let's review the applications and use cases for keyword extraction. Keyword extraction can save countless amounts of human effort because considering that there are billions of internet users per day, it is to say the least that we have a lot of unstructured text data. It is basically impossible for any human being to find what is relevant to them in that sea of text without any sort of filter in place. This is where keyword extraction comes in. It is able to aid humans in a number of tasks, such as business brand monitoring, where companies can monitor whatever conversation is happening around their brand, especially at a time like this when online reputation is vital for a business's success. Customer service in terms of providing customers with the right information while offering fast response times from agents, making keyword extraction a valuable asset. And even customer feedback, as Carlos mentioned earlier. Basically, it is huge for business intelligence purposes because it can leverage information from all kinds of sources, product reviews, and even social media, which we will also briefly go over in a bit. Knowledge management is another topic where keyword extraction is a very big player. The reason why Google search engine is very trusted in a way that when someone does not know something, another person can simply tell him or her to, in quotes, Google it, is because Google has optimized their keyword extraction model for their search engine to a point where a person can find the information they're looking for in the first 5 articles or websites Google provides, if not the first. Keyword extraction plays a big role in making good papers, books, etc. relevant to increase the general knowledge about a certain topic. And on a greater scale, keyword extraction is used towards things that are happening in our daily lives in general. Social media monitoring is a big example where people are free to express their feelings, thoughts, and opinions on a variety of topics. It helps towards something as simple as shopping, where it is able to recommend a product you might also need given your current trends in search queries. Product analytics in terms of being able to quickly read and find the necessary specifications for a tool you require. And keyword extraction also benefits humans when traveling. Being able to read about places so one can do some quick and easy research when going to a place they are unfamiliar with can be essential. With all that being said, we have barely scratched the surface on what keyword extraction can do, but let's move on to the problems regarding keyword extraction. Now that we have talked about the great things about keyword extraction and the fact that it is being used in our daily lives already on a big scale, it's definitely not perfect. So let's talk about it. First, although a lot of famous methods or models do great, their weakness is that they are not as accurate as we want them to be when given small queries. There's also the issue of not having one or two best approaches that effectively extracts keywords from different data sources. This leads to a lot of new methods being made which reduces efficiency in the whole field. For writing reports and such, some sort of human interaction is still required because there is no guarantee that what the keyword extractor returns will guarantee accuracy. For example, a movie review can have multiple, in quotes, negative words, which in turn would be categorized as a negative review, when in reality, the review was saying something like, "There's no movie that can beat this one. I will never stop watching it," which is obviously a positive review that just has the negative words such as no and never. Based on the current problems in the field of keyword extraction, I know that we said that human interaction is still required as of right now, but maybe some research can be done towards making this whole process fully automated. Due to the complexity of this, we are a ways away, but it is definitely worth the time to implement a keyword extractor that makes reports on findings which does not need to rely on any human. Which leads us to the topic of better accuracy, because that is what the method or models will need in order to run completely automated. A first step towards this can be addressing one of the unresolved issues of not having one or two best approaches that everyone can focus on in using. From what Alina had discussed, we have a lot of popular methods or models for keyword extraction. Keyword extraction is one of the most efficient methods of collecting crucial information from unstructured text, if not the most efficient. It dramatically minimizes the time companies devote for gathering necessary information for running the business, and it even helps regular people in doing everyday tasks. With that being said, keyword extraction is an excellent way to find what is relevant in large sets of data. However, it is not perfect. We have talked about what can be improved in terms of automating the process even further. This is definitely a big field in technology already, but it is only growing. Therefore, I personally don't have any doubt that this technology will be taken even further. Thank you for listening to our presentation.